Hi everyone, this video is to go over iReady lesson, graph equivalent ratios.
The Swainson's hawk migrates between North America and South America every year. These birds can fly an average of 100 miles every day to complete the journey. Find how far a hawk can fly in 15 days.
Okay, so we're going to find the unit rate of our table. So if you remember, we're going to label our table as X and Y. And to find unit rate, we do Y divided by X. So we're going to do 500 divided by 5, which will tell us our unit rate is 100 or 100 miles per day. We're going to multiply now all of our days by the number 100. So 15 times 100 will give us 1,500.
Find how far a hawk can fly in 20 days.
20 times 100 will give us 2,000.
Find how far a hawk can fly in 25 days.
25 times 100 will give us 2,500.
Find how far a hawk can fly in 30 days.
30 times 100 will give us 3,000.
Find how far a hawk can fly in 35 days.
35 times 100 will give us 3,500.
Now let's see how Salsa is a sauce that is served with Mexican food, often as a dip. Salsa can be made with a wide variety of fruits and vegetables. When Eric makes a small batch of salsa, he uses 1 cup of chopped onions and 3 cups of chopped tomatoes. He wants to know how much of each ingredient to use in larger batches. Find the number of cups of tomatoes Eric needs if he uses 2 cups of onions.
So what we see here, if we have our X and our Y divided by X will be 3. So our unit rate is 3. So 2 times 3 will give us 6.
Find the number of cups of tomatoes Eric needs if he uses 3 cups of onions.
3 times 3 will give us 9.
Find the number of cups of tomatoes Eric needs if he uses 4 cups of onions.
And 4 times 3 will give us 12.
Good. All of the ratios of onions to tomatoes in the table are equivalent.
Now we can graph.
You can graph these equivalent ratios to see the relationship between the quantities. Plot each ordered pair in the coordinate plane to show the ratio of onions to tomatoes in each batch.
So remember, we have our X and our Y. We see our X is labeled with onions, our Y labeled with tomatoes. So here we go. We have 1, 3, 2, 6, 3, 9, and 4, 12. We know that there are 2 criteria when we want to graph a proportional relationship. It has to pass through our origin and be a straight line. So we see that that is a proportional relationship, which we also know from our table. There's our straight line going through the origin.
Lassi is a traditional Indian drink made with fruit, yogurt, juices, and other ingredients. Anik uses 8 cups of mango and 2 cups of juice when he makes mango lassi for his family. He made a table to show how much of each ingredient to use to make different sized batches. Plot each ordered pair in the coordinate plane to show the ratio of cups of mango to cups of juice in each batch.
So again, we have our X and our Y. We know that this unit rate, if we did Y divided by X, would be a fraction, 1/4, or the decimal 0.25. We're going to plot our points on our graph the same way we would. So 4 mango cups to 1 juice. We're going to go 8, 2, 12, 3, and 16, 4.
Nice. Which ordered pair shows an equivalent ratio of cups of mango to cups of juice?
So we can do this 2 ways. We can either continue to plot our points on the graph, or we can try and divide to see which one of these ordered pairs, when we do Y divided by X, will give us the fraction 1/4 or 0.25. Since we have this handy dandy graph, we might as well use it. And we would see that we're going to increase the mango cups by 4, and we would increase our juice cups by 1. So we would have the ordered pair right here, 20, 5 right here. And we know that if we did 5 divided by 20, it would give us that fraction 1/4 or 0.25.
You got it. The ratio, Mr. Wu loves to make apple crisp. He cuts up the apples and puts a mixture of brown sugar, butter, and oatmeal on top. Then he bakes the dessert in the oven. The table shows the number of apples Mr. Wu needs for different serving sizes of apple crisp.
Okay, we're going to plot them on the graph.
Plot each ordered pair in the coordinate plane to show the ratio of apples to servings.
5, 6, 10, 9, 15, and 12, 20. Now what this tells us, we have y divided by x. Our unit rate is 5/3 or 1.5 per 1. So we're going to keep that in mind as we go on.
Which ordered pair shows an equivalent ratio of apples to serving sizes?
So let's continue our graph here. If we keep moving up by 5 on our y, we'd go from 20 to 25, so we'd be at 25. And we move our apples over by 3, so we'd go from 12 to 15. So our ordered pair would be 15, 25, which we see right here as our point, 15, 25, and we can go on.
The ratio 15 apples to 25 servings of apple crisp is equivalent to all other ratios shown on the graph. Students at West Side Middle School are having a car wash to raise money for an arts program. They want to know how much money they make for washing different numbers of cars. How much money can students earn from washing 4 cars?
So what we see here,
plot a point that shows this ratio,
is that y divided by x will give us 6 divided by 1. So what that tells us, 6 is on the money axis, 1 is on the cars washed axis. So 1 car costs $6. So if we want to plot a point for 4 cars, we do 4 times 6, which will give us 24. So our point will be 4, 24.
Great.
Now what this tells us is our unit rate, which we're going to fill in right here.
Complete the statement about the graph.
So it's 6 times the number of cars washed, because $6 per car.
Which ordered pair shows an equivalent ratio of cars washed to money earned?
So now if we want to wash 6 cars, we know we have to multiply it by $6 per car, and 6 times 6 is 36. So our ordered pair will be 6 cars for $36. We know that the 6 has to go first because X represents the cars washed. So 6, 36.
Central Grill is having a sale when you order at least 2 burgers. Customers can order several burgers at the sale price as long as they are in groups of 2.
Okay.
Plot 2 points that show the price of 6 burgers and the price of 8 burgers.
Is if our 10 is y and our 2 is x, 10 divided by 2 is $5 per burger. So now we can do 6 times 5, which will give us 30. So our point for 6 burgers will be $30. And for 8 burgers, 8 times 5 will be $40. Now we know our unit rate is $5 per burger.
Complete the statement about the graph.
So we type 5 in here and go on.
Which ordered pair shows an equivalent ratio of number of burgers to price?
So we want to figure out which one, because our graph doesn't go high enough, that when we do y divided by x, we'll get the answer 5. We know that 60 divided by 12 is 5, so that's going to be our answer. So 12, 60 is our correct choice.
Way to go!
Thanks.
Lonnie and her friends started a dog walking service after school. They want to know how much money they can earn walking different numbers of dogs. Plot 2 points that show the amount Lonnie and her friends earn for walking 3 dogs and for walking 4 dogs.
On our graph, we see right here, it's $8 for 1 dog. So that'll help us. 3 times 8 will give us 24. So our point will be 3, 24. And then 4 times 8 is 32, so our next point will be 4, 32.
Complete
now
the
we
statement
know
about the graph.
That means that the amount is 8 times the number of dogs walked because it's $8 per dog. And now we want to figure out
shows an equivalent ratio of number of dogs to amount
which
earned.
relationship here, when we do y divided by x, will give us 8. So 64 divided by 8 will give us 8. So our correct answer is 8, 64.
The more players that sign up for soccer camp, the more coaches that are needed. The graph shows the number of coaches assigned to different groups of players.
For 6 players. So each coach gets 6
players. Complete the statement about the graph.
So here we know players is our x value. So this will be 24 players for 4 coaches. So 4 coaches are needed for a group of 24 players. The number of players is always 6 times the number of coaches. Now, how many coaches do we need for 48 players? We're going to do 48 divided by 6, which will give us 8.
That's it.
Now, we want to look at this ordered pair, 42, 6. When we divide this, what we see is that we get an answer of 7. Or 7, 1. So what that says is that there are 7 players for every 1 coach. So this is not an equivalent ratio because we want 6 players for every coach. And what this tells us is that the number of players went up, but the number of coaches did not. So that means that there are less coaches. There's too few coaches for this number of players.
The graph shows the amount of gas that Dario's car uses to travel different distances.
Okay.
Complete the statement about the graph.
We see that he's using 1 gallon of gas for 20 miles, or 20 miles per gallon. So if we have 60 miles, we see from our graph that that is 3 gallons of gas. So we want to write that as an ordered pair. So 3, 60 will be our ordered pair. Now, the number of miles is always 20 times the number of gallons of gas. That's our unit rate. How far is his car traveling on 12 gallons of gas? Well, if we know that he's using 20 miles per gallon, we want to do 12 times 20, which should give us 240. Okay, the ratio at 8, 140, is it equivalent or is it not equivalent? Well, if you take out your calculator and you do 140 divided by 8, it will give you 17.5. We want a unit rate of 20, so we know that this is not equivalent. Now, if normally we're going 20 miles, we know that 17.5 is too few miles for the number of gallons of gas. Quiz time. Okay, here we go.
Travis is planning to ride at a constant speed during an upcoming bike trip. He wants to know how many miles he will ride after different numbers of hours.
Okay.
Plot 2 points that show how far Travis will ride after 3 hours
10
and after
miles
4 hours.
Per hour. So 10 is our unit rate. So for 3 hours, he will go 30 miles. 3 times 10, 30. Now we're going to do 4 times 10 to get 40. So our next ordered pair will be 4, 40.
The points on the graph show the number of miles that Travis rode during the first 4 hours of a bike trip. Travis plans to keep the same speed for the rest of the trip.
Okay, unit rate. That's great.
Complete the statement about the graph.
We know that he's always going 10 miles per hour. So now this ordered pair, 2, 20, is telling us that he rode 20 miles in 2 hours.
Which ordered pair shows an equivalent ratio of hours to miles?
Now we could continue our graph, or we could just continue to do y divided by x. And we know that when we do y divided by x, we're looking for an answer of 10. 80 divided by 8 will give us that answer. So our ordered pair is 8, 80.
Complete the statement about the graph.
So if he's going 60 miles, 60 divided by 10 tells us it will take him 6 hours.
The secret to Chef Allen's award-winning chili is the beans. He makes chili every day at the restaurant, so he buys a lot of beans. Chef Allen wants to know how much he will pay for different amounts of beans. Plot 2 points that show the cost of 15 pounds and 20 pounds of beans.
All right, so what we see here is that it's $4 for a 5-pound bag of beans. We want to keep this going. So at 15 pounds of beans, which we're moving over by 5, from 10 to 15, we also want to move our cost up from 4 to 8 was $4. So from 8 going up, we need to do 12. So our ordered pair will be 15, 12. Next, we're going to have 20, right? Because we have 20 pounds of beans here. And we want to move that up again from 12 up by 4. So that'll go up to 16. So we'll have 20, 16.
The points on the graph show how much Chef Allen pays for different amounts of beans. Complete the statement about the graph.
Okay, so now we know that we want to write an ordered pair that represents the cost of 20 pounds of beans, which on our graph we already found. 20 pounds of beans is going to give us, will be $16. So our ordered pair should look like this, 20, 16. Now we want to do the same thing here, but we want to explain it. So we know that if we have 15 pounds of beans, it will cost us $12.
Which ordered pair shows an equivalent ratio of pounds to dollars?
So let's continue on our graph. We know that our beans has been increasing by 5, so from 20 to 25. And now our price has been going up by $4. So 16 up by 4 will give us 20. So our next ordered pair will be 25, 20. 25, 20. Make sure you select the right ordered pair because there are some tricky ones in there.
Complete the statement about the graph.
So now we know the cost of 50 pounds of beans. All right, so let's think. Our original ratio was $4 to 5 pounds of beans. So to get from 5 pounds of beans to 50 pounds of beans, we multiplied by 10. So that means we need to multiply our cost by 10. So 50 pounds of beans will be $40.
Jing is planning to ride at a constant speed during an upcoming bike trip. She wants to know how many miles she will ride after different numbers of hours. Plot 2 points that show how far Jing will ride after 3 hours and after 4 hours.
So here we see she's going 12 miles per hour. So that means we're going to multiply 3 by 12. So 3 times 12 will give us 36. So our point will be 3, 36. Then we'll also need to do 4 times 12, which will be 48. So we'll need to do 4, 48.
The points on the graph show the number of miles that Jing rode during the first 4 hours of a bike trip. Jing plans to keep the same speed for the rest of the trip.
So we know
the statement about the graph.
Our unit rate was 12 miles per hour, so that's going to be 12. So this ordered pair means that she's going 24 miles in 2 hours.
Which ordered pair shows an equivalent ratio of hours to miles?
Now, when we divide y divided by x, we want to get an answer of 12. And we know that 72 divided by 6 will give us 12. So our correct ordered pair is 6, 72.
Complete the statement about the graph.
So in a 60-mile trip, how long will it take her? 60 divided by 12 will give us 5. So we know a 60-mile trip will take her 5 hours.
Chi uses gourmet noodles to make his famous lo mein dishes. He wants to know the cost of buying different amounts of noodles. Plot 2 points that show the cost of 6 pounds and 8 pounds of noodles.
Okay, so here we see that the cost is $5 for 2 pounds of noodles. That tells us that 1 pound of noodles, we would have to do 5 divided by 2. 5 divided by 2 is going to give us 2.5 or $2.50. So it's $2.50 for each pound. We want to plot a point for 6 pounds of noodles. So if we do 6 times 2.5, it's going to give us 15. What we can also do is think of the ratio. So 5 over 2 compared to blank over 6. So to get from 2 to 6, we multiply by 3. So to get our y number, we're going to do 5 times 3, which will give us 15. So our point is 6, 15. Now we want to do the same thing for 8 pounds. So remember, to go from 2 to 8, we multiply by 4. So we want to do 5 times 4 to give us 20. So it will be 8, 20.
The points on the graph show how much Chi pays for different amounts of noodles. Complete the statement about the graph.
So 6 pounds of noodles, so 6 is our x value, is going to cost him $15. So the ordered pair 6, 15 represents the cost of 6 pounds of noodles. The ordered pair 8, 20 means that 8 pounds of noodles will cost $20.
Which
now,
ordered pair
which
shows
of
an equivalent ratio of pounds to dollars?
Is going to show our equivalent ratio. Now remember, if we do y divided by x, because we see that our graph won't keep going up, we either want to get the simplified fraction of 5 over 2, or if we use the calculator, the decimal 2.5. So let's do this. If we do 10 divided by 25, 10 divided by 25, we get 0.4 or 4 tenths. That's not what we want. Let's keep going. 30 divided by 12 will give us 2.5. Right. Make sure you select the correct one. 12, 30. So 30 pounds of noodles will cost $12. And we're good.
Complete the statement about the graph.
So now how much will 20 pounds of noodles cost? Well, remember, we can either create our equivalent ratio. So to go from 2 to 20, we multiply by 10. So that means 5 times 10 will give us 50. So 20 pounds of noodles should cost $50. All right, make sure you complete your whole entire quiz on iReady, and iReady gives you a grade. Good luck. Stop recording.